In this lecture, I'll be talking about interpod affinity and anti-affinity. This mechanism allows you to influence scheduling based on the labels of other pods that are already running on the cluster. Pods belong to a namespace, so your affinity rules will apply to a specific namespace. If no namespace is given in the specification, it defaults to the namespace of the pod. Similar to node affinity, you have two types of pod affinity and anti-affinity. You have the required during scheduling, ignored during execution, and the preferred during scheduling, ignored during execution. The required type, the first one, creates rules that must be met for the pod to be scheduled. The preferred type is a soft type, and the rules may be met. So in the preferred type, the pod should always be scheduled. In the first one, if the rules are not met, then the pod will not be scheduled. So interpod affinity and anti-affinity is very similar to the node affinity and anti-affinity, just that here we do it on a pod level in a namespace instead of a node level. A good use case for pod affinity is co-located pods. You might want that one pod is always co-located on the same node with another pod. For example, you have an app that uses Redis as a cache and you want to have the Redis pod always on the same node as the app itself. Another use case is to collocate pods within the same availability zone. So it's the same as the previous use case, but rather than on a machine basis, you can do it on an availability zone basis. So then the pods are collocated within the same availability zone. If you have multiple zones, then these pods will only be scheduled within one zone. When writing your pod affinity and anti-affinity rules, you need to specify a topology domain called topology key in the rules. The topology key refers to a node label. If the affinity rule matches, the new pod will only be scheduled on the nodes that have the same topology key value as the current running pod. This is a bit hard to understand without an example, so let me show you an example. Here we have two nodes and we have one pod on our node 2 called pod, and it has the label app with the value myapp. We want to schedule a new pod on the left here that has the label app equals Redis. This pod has this in its specification. It has pod affinity, required during scheduling, ignored during execution. It has a label selector, and the match expressions is app in myapp. So it's going to match this app here, this pod here on the right. And when it matches, then the topology key is important. Here we says the topology key is Kubernetes IO/hostname. So that's the host name of the node. So if the expression matches, then this pod will be scheduled on the node that has the same topology key value. So the value of Kubernetes IO hostname is node 2 in this case. So this pod will only be scheduled on a node that has this label kubernetes.io/hostname equals node 2. And this is only one hostname. So that's going to be node 2. So then the new pod is scheduled on node 2 and not on node 1. Let me show you another example. Here we have three nodes. Node 1 and 2 are in EU West 1A and node 3 is in EU West 1B. So the first two are in the same zone. We want to schedule a new pod. This has the label app equals DB. And the pod affinity is exactly the same as the previous one, except the last line. In the last line, we say topology key is the failure domain beta Kubernetes IO zone. So here, if our expression is true, the expression is here app in myapp. So if there's a pod app equals myapp and this is true, then this new pod will be scheduled on a node with a label failure domain beta Kubernetes IO/zone equals the same as the node where the pod is running on. So pod app equals myapp is running on node 2. Node 2 has as a zone EU West 1A. So the new pod is going to be scheduled either on node 1 or either on node 2, but never on node 3. So if we have replication factor 2, then the chances are high that one gets scheduled on node 1 and one gets scheduled on node 2. So never on node 3. So this is a difference with the topology key. Contrary to Affinity, you might want to use pod anti-affinity. You can use anti-affinity to make sure a pod is only scheduled once on a node, for example. For example, you have 3 nodes and you want to schedule 2 pods, but they shouldn't be scheduled on the same node. Pod anti-affinity allows you to create a rule that says to not schedule on the same host if a pod label matches. So here we have again 2 nodes. We have a pod running, which is app equals my app, and we're going to schedule a new pod with the label app equals db. Now we're going to use pod anti-affinity in our specification. The expression is still app in my app, so it will match the current running pod, and the topology key is the host name. Because it's anti-affinity, it will not schedule when the expression matches on the same host name. So where does it go? It goes to node 1, because node 1 has a different host name than node 2. So this is basically just the reverse of pod affinity. Anti-affinity makes sure that it doesn't get scheduled on the node with the same topology key value. When writing pod affinity rules, you can use the following operators. In, not in, does a label have one of the values that you specify? And exists, does not exist, does a label exist or not? Interpod affinity and anti-affinity currently requires a substantial amount of processing. You might have to take this into account if you have a lot of rules and a large cluster, for example if you have more than 100 nodes. And then in the next demo I will show you an example of interpod affinity and anti-affinity.